Finding exomoons, regular satellites of universes past our planetary group, would be exciting. For a beginning, they might assume a key part in deciding the livability of host planets by damping their wobbles, cultivating a steady environment, similarly that our moon has accomplished for Earth. They could likewise come in strange and brilliant designs. For example, rings of endlessly moons with their own moons. Yet, most excitingly, it is conceivable that some of them are more friendly to life than exoplanets. Exomoons are challenging to identify and affirm utilizing current methods, and to date, there have been no affirmed exomoons identified. Livability likewise requires that the exomoon have major areas of strength for enduring. It isn't sufficient that the surface temperature of an exomoon be reasonable for fluid water. The exomoon has the essential surface gravity to keep the departure of fluid water from its surface. Our own moon, however huge as it seems to be, misses the mark concerning the important surface gravity. Indeed, even a moon as extensive as Venus would miss the mark. The exomoon would have to have the mass and thickness of Earth. On that occasion, the planet-moon framework might be all the more precisely named a paired planet. Exomoons are probably going to be tidally locked to their planet and consequently experience days a lot more limited than their orbital period around the star and have seasons, all of which works for livability. These satellites can get more enlightenment per region than their host planets.
Oh. Man, you are really bouncing.
As the planet mirrors heavenly light and emanates warm photons. Likewise, exomoons circle a bigger planetary body. They have an extra arrangement of limitations on their possible decency than exoplanets themselves. Models incorporate obscurations by their host planet, as well as reflected daylight and intensity outflows. In particular, gravitationally prompted flowing warming by a host planet can decisively affect a moon's environment and topography. Fundamentally, contrasted with planets, exomoons have extra wellsprings of energy that can modify their energy financial plans, which, if excessively high, can turn a mild, possible heaven into a burned no man's land. Going against the norm, obscurations can altogether adjust neighborhood environments on exomoons by lessening heavenly enlightenment. Notwithstanding radiative warming, flowing warming can be exceptionally huge on exomoons. Perhaps even enormous enough for sanitization. We distinguish blends of physical and orbital boundaries for which radiative and flowing warming are sufficiently able to set off an out-of-control nursery. An excess of surface gravity could be similarly as large an issue as excessively little. An exomoon that acquires an enormous part of its surface temperature from flowing warming would be far enough away from its host star that, assuming it has a surface gravity any more noteworthy than Earth's, it could hold a lot of smelling salts or potentially methane for the presence of non-exotic types of real life. The perceptions from missions, for example, Kepler have noticed various candidates. 2 potential exomoons that might circle rebel planets have likewise been distinguished by microlensing. In September 2019, cosmologists revealed that the noticed dimmings of dark-striped Cat's star might have been delivered by pieces coming about because of the disturbance of a stranded exomoon. Some exomoons might be potential. Like an exoplanet, an exomoon might possibly become tidally locked to its essentials. Be that as it may, since the exomoon's essential is an exoplanet, it would keep on turning comparative with its star, subsequent to becoming tidally locked, and consequently would in any case encounter a day-night cycle endlessly. Additionally, exomoons are more convoluted than exoplanets. They have more issues. However, they likewise have a bigger number of chances than planets to be tenable, said Barnes. There is a tenable zone for exomoons. It's somewhat not quite the same as the livable zone for exoplanets. Around 850 extrasolar planets, planets outside the planetary group, are known, and the greater part of them are sterile gas Goliaths like Jupiter. A couple have a strong surface and circle their host stars in the livable zone, the circumstellar belt at the right distance to permit fluid surface water and a harmless climate possibly. A base mass of an exomoon is expected to drive an attractive safeguard on a billion-year timescale. Exomoons could address a totally new kind of cosmic article, and their revelation could have expansive ramifications. Exomoons are up to this point that we can't see them straightforwardly, even with the most impressive current telescopes. Makes sense to Dr. Renee Heller. All things considered, telescopes record the variances in brilliance of far-off stars, the time series of which is known as a light bend. Specialists then search for indications of moons in these light bends. If an exoplanet passes before its star as seen from Earth, it diminishes the star by a minuscule division. This occasion is known as a travel, and it rehappens consistently with the orbital time of the planet around the star. An exomoon going with the planet would have a comparative darkening impact. Its follower in the light bend, nonetheless, wouldn't just be altogether more fragile. Because of the development of the moon and planet around their common focus of gravity, this extra darkening in the light bend would follow a fairly confounded design. Also, there are different impacts to be thought of. For example, planet-moon shrouds, normal brilliance varieties of the star, and different wellsprings of clamor produced during adaptive estimations. Another chance is that the moon, whatever its size, has created some distance from its planet over the ages. Today, the exomoon is generally 1.9 million miles, 3 million kilometers, from Kepler 1625b. Notwithstanding, researchers realize that the Earth's moon is slowly creating some distance from our planet at a pace of around 1.5 inches, 4 centimeters each year. The applicant exomoon, indications of which were spotted by NASA's Kepler and Hubble space telescopes, may have correspondingly edged away from its planet after some time, so it might have been a lot nearer billions of years before, Kipping said. Exomoons are significant features of the meaning of exomoons, or moons circling exoplanets, in different fields of cosmic examination. Regardless of the set number of exomoons found up to this point, there is compelling conviction that they should exist, and concentrating on them has prompted the idea of a wide assortment of new planetary frameworks. The quest for exomoons is fundamental for tracking down a tenable moon and for understanding the tenability of exoplanets. Understanding the development and advancement of exomoons could give basic data about the worlds and their definitive development, as well as help to find exoplanets with a higher potential for tenability. Finally, distinguishing and examining exomoons is vital in recognizing biosignators in the universe and in understanding the job that exomoons play in creating life.